In this video, we're doing a demonstration of the Leap Sensor Manager software with data coming in from a motor monitor transceiver node. We'll graph the data, show how baselines can be set to predict failures and prevent unplanned downtime. All right, let's take a look at the software and we'll see the data coming from the motor monitor. We have the device, unique device ID, which we can actually rename. We have the thermocouple temperature, the amp clamp current, which is 0 right now because it's 0 amps. And then we have 8 different vibration parameters that are used to describe and monitor the vibration of the motor. All right, there's some really cool features in the software that I want to show next. I'm going to click on this Show More button, and we're going to go down and graph the data. So the first thing is the thermocouple, and you can see it bouncing around a few degrees here. But there's our amp clamp. You can see right here is when it was on low speed and then bumped up to high speed. And you can see how steady it is. If you were to set an alarm limit up here, that would be a great indication of catching a failure. Now let's go down and look at the vibration data. Again, you can see where we are on the low speed here and then bumped up to the high speed here. And then once we're at the high speed, it's fairly steady. So the theory says that when a motor starts to fail, the vibration will almost double. So if you set your limit at about 50% above each one of these levels, there's a really good chance you're going to catch the motor failure. So these are all acceleration RMS and acceleration max readings. And then we also have the radial velocity readings here. All right, I wanted to take one more look at the graphs to show some of the capabilities. On this vibration graph down here, you can turn off the viewing of certain ones, and we can look at just this green line and zoom in. We can see that when the fan is off, it's about 0.035. On low speed, 0.04. So even though that line doesn't show much of a difference, it's actually detecting about a 30% change. And then here, of course, is the fan at full speed, and here's the amp clamp. Let's just go ahead and turn it on one more time just to get a feel for how the system graphically displays what's going on with the motor. So there, our vibration has kicked way up again. You can zoom in and see what's happening. There's our first amp clamp point, and there's the other one. So real effective graphing, and that's really helpful to set the initial baselines and then add about 50% above that for your alarm limits. From the graph, you can see how easy it is to set baselines and then set alarms. We can also scroll up here and quickly see what the settings are on the device node. We can click on history, and we can also see what alerts are set. Up here on the main part of the software, we can configure the device node to change its sample and transmit interval. We can download all the readings to an Excel file, and we can set text, telephone, and email alerts on any of these parameters shown on this page. In some cases, advanced maintenance programs will want the raw vibration data to do thorough FFT analysis offline. The Leap system has the capability to put all 50,000 data points in a file and send the file over the air. This takes a lot of battery power, so it may only be done once every few weeks or few months. This bulk vibration data option facilitates very efficient vibration data collection for advanced offline analysis. Thanks for watching our demonstration. We understand that every application is different. Please contact us for an expert consultation to assure your first system is a quick success.